All right, our topic for today is systems of equations. And here's what this means, okay? This right here is an example of a system of equations. And here's what we're looking for. We're looking for an x and a y that when I plug the x into this equation, it gives me 11. And when I plug the same x and y into this equation, it also gives me negative 9. So I'm looking for a solution that works for both equations. Okay? So if you think about a solution that works for the top equation, let's say x were 4 and y were 1. That would work, wouldn't it? Let's plug 4 and 1 into the top equation. 2 times 4 plus 3 times 1. And the question is, does that equal 11? Well, 2 times 4 is 8, plus 3 does equal 11. But that would also have to work for the bottom equation. Let's plug it into the bottom one. So I've got 3 times 4 minus 4 times 1, and that would also have to equal 11. Well, 3 times 4 is 12, minus 4 equals 8. It does not equal 11. So this right here could not be a solution to the system of equations because that x and that y did not work in both equations. So the question was, I thought the bottom equation was supposed to equal negative 9, and you're exactly right. It's not supposed to equal 11, it's supposed to equal negative 9. But in this case, what did it equal?
8.
And 8 still isn't negative 9, is it? And so this solution right here, okay, does not work for both. It worked on top, it made it all equal to 11, but on bottom we wanted the whole thing to equal negative 9. It doesn't equal negative 9, it equals positive 8. So here's the whole idea of a system of equation. You're looking for an x and a y that when you plug it in both of them, you get a true statement. Okay? Now there are 3 ways to solve system of equations, and we're going to learn all 3, but today we're going to start with the easiest one. The easiest way is by graphing them. Okay? When you graph them, you're looking for where the 2 lines intersect. Where the 2 lines intersect is your solution. Now the second way is something called substitution. And the third way is elimination. Okay? So we're going to start today with graphing. And when we master graphing, we'll go to substitution and elimination. Now here's the thing is, this whole 9 weeks we've been talking about graphing. So the first one's going to be real easy for y'all because you're already prepared. Alright, so here are the 2 equations, and I just got done telling you that in order for you to see where the 2 equations, the solution for the 2 equations is, you got to know where the 2 intersect, right? So when I graph this line and I graph this line, where the 2 lines touch each other, that's the solution. Well, if I want to graph those, I need to get y by itself on each, don't I? Let's get them in slope-intercept form. So on this one, I'm going to subtract 2x on both sides, and I have 3y equals negative 2x plus 11. And then I'll divide by 3 on everything, and I have y equals negative 2x over 3 plus 11 over 3. So that's my first equation in slope-intercept form. Let's go get the second one in slope-intercept form. On this second equation, I am going to subtract 3x on both sides. And so I have negative 4y equals negative 3x minus 9. And then I will divide by negative 4 on both sides. And so I have y equals 3 over 4x plus 9 over 4. So those are my 2 equations that I want to graph. So what I added on the screen was a coordinate plane, and let's graph this first equation in black. So 11 over 3 is the same thing as 3.6 repeating. And so my y-intercept is 3.6, which is about right here. And then I've got to graph my slope. My rise is down 2, and my run is right 1, 2, 3. And so here's my other point. Okay. So now I need to connect those the best I can. Now on the iPad, it's really hard to get a perfectly straight line. But in system of equations by graphing, it's even more important that you use a straight edge. Okay. Now let's graph the blue line. When I graph the blue line, I got to go on the y-intercept to 9/4. 9/4 is like 2.25, which is about right there. And then from there, I got to go up 3, 1, 2, 3, and write 1, 2, 3, 4, and put another point. And I'm going to do the best I can to get as straight a line as I can. I wish this app would make it where I could just draw a straight line. Now, can you clearly see where the 2 points intersect? Yeah, they intersect right here, don't they? Okay. That looks like the point 1, 3. Okay. That is the point 1, 3. Okay. Which tells us that x equals 1 and y equals what? 3. The reason I knew it was x and y is because the first number is x and the second number is y. Right? So now let's go back and test it. Alright, so here are our two equations we had, and we said the solution was 1, 3, didn't we? Yeah. That's x equals 1 and y equals 3. Isn't it? Yeah. And so let's test them. So on the first equation, let's go ahead and plug in 1 and 3. So I got 2 times 1 plus 3 times 3, and that has to equal 11, doesn't it? Well, I've got 2 plus 9 must equal 11. Well, does it? Yeah, here I've got a true statement. Boom, it worked, didn't it? But it doesn't matter if it worked on the first one if it doesn't work on the what? Okay, so I've got 3 times 1 minus 4 times 3 must equal 9. Negative 9. So that's 3 minus 12 must equal negative 9. Well, what is 3 minus 12? So negative 9 does equal negative 9, so we got the right answer. So what I did right there was checking my solution, right? When you get an answer, you don't just say, here's my answer. Go back and make sure it works for both. So we solved that system of equations, this and this, and here was our answer.